Welcome Wildcats. Today we are going to be looking at 3.2's homework assignment. So this is going to be solving linear systems in 3 variables as a homework assignment. So you can see here that I've got pulled up on your left, I have the homework assignment, and on the right I have the Desmos matrix calculator, the easiest way to solve the problems that we have. So let's go ahead and start with problem 1. I am probably not going to solve all of these problems because they are all very, very similar in their solution manner. For example, number 1, solve the system using substitution. We're not going to use substitution, we're going to use matrix math. So for that, we're going to open up a new matrix. This is a 3-row, 4-column system. So 3 rows, 4 columns. And we are just going to list these straight across as we see them. So the coefficient of 4x is 4, coefficient of y is 1, coefficient of negative 2z is negative 2, and then we have negative 2 for our answer column. For our second row, we still have x, y, z constant, so x, y, z constant. So we can just read the coefficients from left to right again. 2, negative 3, 3, 11. Our final row, though, does have something a little different. You'll notice that there is no z. Because there's no z, we're going to have to do x is 1, y is negative 3, and since there are no z's, we're going to put 0, z. And on the equal side, we have 1. We hit enter. Our next step on the matrix calculator is to go to row reduced echelon form, tell it the name of the matrix we're working with, and then we're looking for a diagonal of 1s, which we have, surrounded by 6 zeros, which we also have, and that tells us that our answer is the final column, top to bottom, in that order. So x in parentheses, x is 1, comma, y is 0, comma, z is 3. So 1, 0, 3 in that order. Moving on to number 2. Again, they're asking for us to do this through substitution. You'll notice we do have a couple of decimals here. So let's start ourselves a new matrix. Once again, 3 rows, 4 columns. Across the top, coefficient of x is 1, 5y is 5, 3z is 3, and our answer is 3.75. Notice that in our second equation here, we are missing an x, so we're going to plug in 0x, giving us 4y, negative 1z, and 3. Next, we have 6x, but we're not going to put in the x, just the 6, negative 2y, 4z, negative 1.5. Getting our row reduced echelon form. Looks like we have our diagonal, our 6 zeros, so our answer is 0, comma 0.75, comma 0. 0, comma 0.75, comma 0. Oh, looks like I plugged something in wrong, so let's take a look. I have 153, 3.75. 153, 3.75, 0, 4, negative 1, 3, 6, negative 2, 4, negative 1.5. I don't see anything plugged in incorrectly. Ah, there we go. Right here. I typed in a decimal point instead of a comma. Mistakes are very, very easy if you are trying to go too fast. Okay, this problem is basically the same as the previous 2, so I'm going to skip it. Number 4 is exactly the same as the previous 2, so I'm going to skip it. Same with number 5. Number 6 is the same, but I'm going to go ahead and do number 6 so that I'm not skipping them all. Alright, so for this one, across the top we have 4x, 1y, negative 2z equals 18. Second row, we have 2x, negative 3y, 3, and 21. And on our last row, we have 1x, negative 2y, There is no z, so we have 0 z's equals 6. Once again, row reduced echelon form. This time we are named matrix C. And I have 1 in the diagonals surrounded by zeros. And that looks like a 6 to me, which would be 6, 0, 3 in that order. 6, 0, 3. Number 7. Notice that this one says enter fractional answers in decimal form. So they want you to put in decimals, not fractions, for this answer. We'll go ahead and do this one. I see 1, 5, 3, 8, 0, 4, negative 1, 3, 6, negative 2, 4, 24. If you have any issues seeing where I got any of those, please go back to the last couple of problems where I explained where those came from. Row reduced echelon form for D gives me a diagonal of 1 surrounded by zeros, so 4.25. Top to bottom, I've got 4.25, comma 0.75, comma 0. And one, 5, 3, 8, 0, 4, negative 1, 3, 6, negative 2, 4, 24. 4.25 Atkins. 4.25. Number 8. This is the exact same thing, except this one is going to have an awkward number of solutions. So let's go ahead and do this one so we can get an example of that. So new matrix, 3 rows, 4 columns, 2, negative 1, 3, 13, negative 6, 3, negative 9, negative 39, and 4, negative 2, 6, 26. Row reduced echelon form for E. Okay, I do not have a diagonal of 1s, but my bottom column, or my bottom row, is 0, 0, 0, 0. Since they're all zeros, that tells me the system has infinitely many solutions. Okay. This one is the same as previous questions. Alright, here we have the first problem that might give you some interesting issues. This one, we're actually going to have to do in 2 parts here. So first thing we need to do is hide Desmos and show this. So let's hide Desmos, pull up our IPEVO. The first thing we need to recognize that we may not remember from previous years and previous classes is what the equation for a parabola is, because they're asking us to find a parabola that passes through these points. But the equation for a parabola is y equals ax squared plus bx plus c. And they're giving us 3 points to work with. The first point is 3, 14. Well, that means if I plug in a 3 for x, and a 3 for this x, I'm going to get a 14 for y. A plus b plus c. And 3 squared is 9, so this is 9a plus 3b plus c. 14 equals that. But something that you might remember is if I remove this 14 to the other, if I move the 14 equals and just flip these all to the opposite sides, I'll have 9a plus 3b plus c equals 14. Now what do I have? I have a linear equation with 3 variables, but instead of being x, y, z, they are a, b, c. I used one of the 3 points to get this. 9a plus 3b plus c equals 14. That gives me one of my three equations. So in Desmos, with a new matrix, 3 rows, 4 columns, my top row is going to be exactly what I just had, 9, 3, 1, 14. You can see that again on my pad here, 9, 3, 1, 14. 9, 3, 1, 14. So that's my first of three equations. But remember, since I have three variables, I need three equations. So I'm going to rewrite this, ax squared plus bx plus c equals y. Well, my second equation is 30. Or my second point up here is 30 comma negative 4. So 30 squared plus b times 4 plus c equals negative 4. So I have 30 squared is 900 because 3 times 3 is 9 and 10 times 10 is 100. So 900a plus 4b plus c equals negative 4. This is my second equation, which I can put up on Desmos. So I need 900, 4, 1, negative 4. My third equation is going to be this third point, 0, comma 6. So I've got ax squared plus bx plus c equals y. A times 0 squared plus b times 0 plus c equals 6. So this is 0, a plus 0, b plus c equals 6. So this is the last equation I needed. And all I have to do is plug it into Desmos. I need 0 plus 0 plus 1 equals 6. Enter. Row reduce. And that is a rather ugly number. But if I turn it into, that is still a very ugly number. 900, 4, 1, negative 4. Oh, that's because, is that a 6? That was a 6. 9, 3, 1, 14. Oh, I plugged in a 4. I see what the problem is. You can usually tell on these if you've made a mistake. So you can see here I put 904, but this 4 is not accurate at all. This was supposed to be x, and x was 30 for this problem. So that should be 30b. So in Desmos, I need to replace that with a 30. You can usually tell you've made a mistake when you get an answer and the numbers are obnoxious and look like they make no sense. Now that looks much more reasonable. Negative 1/9, 3, and 6. So now what I need to do though is I need to plug the equations that I've got, which is negative 1/9, 3, and 6. I need to plug that back into this equation. So a is negative 1/9 x squared plus 3b plus 6 equals y. And they've got y equals on the other side here, but that's okay. So we can do negative 1/9 x squared plus 3b plus 6, and then it equals y is on the outside already. Double check Desmos and make sure I've got the right answer. Oh, 114, 016, negative 1 over 9x squared plus 3b plus 6. Do I not like that being the sign that I used for negative? I don't know why they don't like this, so what I'm going to do is I'm going to trash this whole thing and try to type it back in myself. So we'll do negative 1 over 9 x squared plus 3x plus 6. Oh, I had a b here. That should not be b. That should be x. There we go. Alright, next question. We have the triangle of x, y, z. X, y, z. Okay, so we know that, x, y, z. We know that a triangle's three measurements, three angles, equal 180 degrees. So x plus y plus z equals 180. That gives us our first equation that we need for our system of equations. So I know you guys can't see it. I'm going to pull Desmos up, and our first one, new matrix, 3 rows, 4 columns, we have 1, 1, 1, 180. Next part of the question says the measure of angle x, is 8 times the sum of the measure of angles y and z. So x equals 8 times y plus z. Okay, so that means x equals 8y plus 8z, using the distributive property, multiplying that 8 through, which means I need to move y and z to this side, giving me x minus 8y, remember, changing sides, changing signs, minus 8z equals, and then if I move 8y and 8z both over to the left side of the equal sign, what am I left with? Yeah, absolutely nothing. And nothing is a fancy way of saying 0. So on Desmos, we are going to say 1, negative 8, 0. Alright, and finally, our third equation says y is 3 times z. Well, once again, we can just move the 3z over to the other side. And if I move everything from the right to the left, then we have a 0. So we've got 0x plus y minus 3z equals 0. 0x plus 1y minus 3z equals 0. Those are our three equations. I can row reduce echelon form this one, and it looks like my three angles are 160, 15, and 5. So x is 160 degrees, y is 15, z is 5 degrees. So this is actually a very, very wide, and like that. It's a very, very steep triangle. All right, number 12. Once again, we're going to be using some detective skills to pull numbers out of the problem and get them into an equation. So the combined ages of three relatives is 120 years. So I'm going to say that we have, since they're asking for it with Dan first, then James, then Paul, I'm going to say our equations are going to be Dan plus James plus Paul. And we know that all of their ages put together is 120 years. So D plus J plus P equals 120. Put that into Desmos real quick. New matrix, 3 rows, 4 columns. So we have that set up. And we said that D plus J plus P equals 120. Okay. James is 3 times the age of Dan. James is 3 Dan. So, moving the 3D to the other side, that's negative 3D plus J, which was James, equals 0 because we moved everything from that side. So we can get that one plugged into Desmos. We have negative 3D plus 1J plus 0P equals 0. And finally, where did it go? There it is. We have James is 3 times the age of Dan, and Paul is 2 times the sum of the ages of, so Paul is 2 times the sum of James and Dan. So once again, distributive property, P equals 2J plus 2D, and if I move the J and the D over here, I want D first, so negative 2D. I want James second, so negative 2J. I want P last, so plus P. And if I move everything from the right over to the left, that leaves me with 0 on the right. This is our final equation. We have negative 2, 1, and 0. Getting our equal sign, we need row reduced echelon form, and this is matrix H. Looks like their ages are 10, 30, and 80. So Dan is the youngest, he is a little boy, 10 years old. James is 30 years old, and Paul is 80. Alright, number 13. At a stock exchange, there were a total of 10,000 shares sold in one day. Stock A had 4 times as many shares as stock B. The number of shares sold for stock C was equal to the sum of the numbers of shares sold for stock A and B. How many of each shares of stock were sold? This problem is done exactly like the previous two. You're going to turn the words into equations just like I did, and using those 3 equations you're going to plug those into matrices and give your solution. I'm going to let you guys do this one on your own. 14. Complete the explanation on how you know when a system has infinitely many solutions or when it has no solutions. If when solving the system you get a true statement such as 0, 0, then that system has infinite solutions. But if when solving the system you get a false statement, then you have no solutions. And our last question. Complete the explanation of why the following system of equations can't be solved. I hope you guys remember this. I mentioned it in class several times, but if I have 3 variables, I need to have at least how many equations? 3. You have to have at least as many equations as you have variables. So when solving a system of equations, there must be at least as many equations as there are variables. Alright guys, I know I skipped quite a few. I skipped one of the word problems. So I skipped number 13, and then I skipped 4 of the other problems. You guys are more than capable, especially those first 4 that I skipped, of doing those on your own. And I really want you guys to give number 13 a try, because it is just like the other 2 examples I gave you. So guys, I hope you are able to get through these all right, and good luck, Wildcats.